What's up? I'm back. Third installment of this series where I'm going to talk about operators. There are a lot of operators in JavaScript, and not all of them are useful for beginners. So I'm going to only show a subset of the operators, the ones that I know that you are likely to use in your first few months of programming in JavaScript. As you can see, I already have a developer tools window open. This looks a little bit different, and that's because I'm using the browser that I typically use to develop with, which is Firefox Developer Edition. All I did was I clicked here and I just separated out the window. And because this is the Developer Edition version of Firefox, the console is a little bit different. I believe it's a lot easier to use. Makes a little bit more sense to me. You can feel free to continue using whatever developer tool that you are using at the beginning of this. All right, so let's do a quick recap. We learned about variables and we learned about the values and their types, right? So operators, they often deal with variables or values. Another way of saying this, they deal with expressions, but we'll get into that in another video. So let me go ahead and create a variable. I'm going to call this sum. And let's set it equal to, let's set it equal to 5. And let's use our first operator, plus 5. Now, if I run this, you should expect for this to put the value of 10 inside of sum. And in fact, that's what's going to happen. So if I come here and let's say that I type in sum, we get back 10. So let's take a little bit of a step back to understand what's happened here. We already know that we can assign values to variables. So we already know that this is an assignment operator. This is the first operator that you saw. Now, it's important to understand that we have a few different types of operators. We have unary operators as well as binary operators. We also have a ternary operator, but I'll get into that a little bit later. But for now, let's understand what a binary operator is. And the reason why I'm going to start with binary is because that's the one that we're using now. Right here, this plus. Now, you may remember in grade school, you learned something about operands, the things that operators operate on. Well, a binary operator must be in between two operands, and that's what we have here. Our two operands are 5 and 5. Maybe I should have did different values, but I apologize. Our two operands are 5 and 5, one on the left and one on the right of the operator, which is plus, right? So let's introduce another operator. These, by the way, are called arithmetic operators, the ones that I'm going to introduce first. So let's do sum is equal to, actually, we don't want to do sum. We'll say let diff equal to, and I'm going to use something different. I'm going to use our variables this time. So we're going to say the diff is going to be equal to sum minus 4. All right. And if I were to write that out, we see that we get back 6. Again, this is just a subtraction operator. It works just like you'd expect on your calculator. How about that? It's like the calculator minus. And this is also a binary operator. And let's move on to the next one. Hopefully you'll understand what's coming. It's multiplication. So we'll do let mult. And this time I'm going to say sum times, and this is an asterisk. To get to that key or that character, you press Shift 8, and that'll give you an asterisk. That's the character that we use for multiplication. So we're going to do sum times diff. And let's see what we get back. Hopefully you'll understand we should get back 60, hopefully. All right, and we get back 60. All right, next operator is division. So we'll go ahead and say let div equal, let's do mult divided by 6. Let's do 2. We'll do divided by 2. And we get back 30. So these are the 4 main operators that we use in arithmetic. We do have a few others, so I'm going to go ahead and go through those. We also have a way to do exponentiation. The way we can do that is let's say let exp equal, let's do 2 And exponentiation is just 2 asterisks together. So we'll do 2, 4. So this should be 2 raised to the 4th power, which I think is 16, maybe. I don't know. We'll see. Yeah, it is 16. Right? So hopefully this is all pretty simple. Most operators, at least most of the binary operators, they operate the same way. Now, there is this thing called precedence. Different operators are evaluated in different orders based off of some precedence. This is not that dissimilar from what you learned in grade school with PEMDAS. I think that's the acronym, which I think is parentheses, exponents, multiplication, division, addition, and subtraction. I think. Don't quote me on that. I actually don't remember it. But in any case, we have the same type of precedence in our programming languages, which is kind of cool. Okay. I'm also going to introduce one more arithmetic operator, and this is called the modulus operator. Or another way you can think of it is we have division, and as you know, division typically is how many times can one number go into another number in like whole, like how many. Yeah, I think that's a good way of saying it. I don't know how division works, but I want to say that ideally you want to understand how many times a number can go into another number fully. And typically you're going to be left with a remainder. Like on your calculator, that remainder will be expressed as a decimal or a fraction. In JavaScript, it's also expressed as that, but sometimes we actually want just a remainder component. So the modulus operator will give us that remainder. Let me show what I mean. So let's do let, we'll call this REM for remainder. And we're going to say 5 divided by 2. So with this particular expression, we're going to get back a decimal, but we may not actually want that. Let's see what we get back. So we'll do that. We get back 2.5. Well, the part that we care about for the modulus is this bit right here, the remainder. So instead of giving back this 2, we just want to know how many, like, what's the remainder of taking 5 divided by 2? In this case, it should be 1, right? So you should have 2 remainder 1. The modulus operator is going to give you the remainder. So let's see what that looks like. So we'll set rem equal to 5, and we're going to use modulus this time. And what we should get back is 1. All right, because like this right here, this says 0.5, but you should really read that as 1 over 2, because that's actually what we're doing. If we're doing 5 divided by 2, whatever that remainder is has to go over 2. So that's why we get back 1 here. And hopefully you'll agree, if we have 2, 4, 5 minus 4 is 1, but we were divided by 2, so we put it over. Yeah. So anyway, this is the modulus operator. It's fairly useful, and you may see it more often than you think. That's it for arithmetic operators. Next, we're going to go into relational operators, and let's go off with the first one. So let's do less than. So it's often the case that we want to be able to compare 2 different values. We want to figure out which value is larger or smaller. Now, some types this does not make sense, but for numbers, this obviously makes sense. So let's do, I'm going to say GT. Actually, I'm not even going to do this. We're just going to type in expressions. I'm not really going to go into what expressions and statements are yet, but I want to at least start introducing you so that when I eventually talk about it, it's not foreign. All right, so let's get started with this. So let's do 5 less than 4. This is going to evaluate to a Boolean. So it's asking the question, is 5 less than 4? No, right? Or put another way, is 4 bigger than 5? The answer to that is also no. So if I were to execute this, we'll see that we get back false. 5 is in fact not less than 4. This character is, if you press shift, comma, this is going to give you that, like the less than symbol. Now we can make this expression true. We know that 4 is less than 5, so let's change this to a less than, right? So, or greater than, really. So 5 greater than 4, we should get back true because 5 is in fact greater than 4. It's a bigger number. We also have a greater than or equal to operator. And it behaves just like the greater than, except we also want to know whether or not it's equal. So if I do this, we'll see that we get back the same value. We get back true because 5 is in fact greater than or equal to 4. Notice that only one of those conditions needs to be true. It needs to either be greater than or it needs to be equal, one or the other. If I change this to 5 is less than or equal to 4, I should still get back false because 4 is still less than 5 and it's also not equal to 5. However, if I did this, we get back true because 5 is less than or equal to 5. Remember, this is two conditions. It's either a less than or it's equal. In this case, 5 is equal to 5. So we get back true. And if I change this to a greater than or equal to, I also get back true because it's still equal to 5. Hope that makes sense. I'm kind of going to gloss over that because I think it makes a lot more sense to see this in action versus me just kind of explaining it. We'll see it in action when we start building small programs, and that's coming soon, actually. I'm trying to build up enough so that I can actually start showing interesting things. We also have other types of operators for relational, but I'm only going to talk about one, and that is the in operator. The reason why I'm going to talk about in is because I've already introduced to you what an object is. The in operator essentially returns a Boolean that tells you whether or not a particular key is inside of an object. Let's see what that's like. Let's create an object. So I'm going to say const, we'll say let, obj. And we'll say first name, or we'll just call it name. And we'll say iPhone. And we'll say version. And I think 14 is the latest version, maybe. I think that's the latest version of iPhone. All right. So let's go ahead and execute this, and then we get back our object. So if I do this, we get back name iPhone version 14. So let's understand how to use this in operator. So I can say, name in obj. Sorry, you have to use it as a string. We get name in obj and we get back true. Why do we get back true? Well, if we look at this object, we see that there is in fact a property called name. Remember, objects are just a collection a collection of key value pairs. This is the key. This is the key. This is the value. These are also known as properties, object properties. So, it's given back true because name is in fact a property of this particular object. Let's see what happens if I put in age. We should get back false. The reason we get back false is because if we look at this object again, there is no property in here called age. However, there is a property in here called version. So let's see version. You get back true. That's all the in operator does. And notice that this is also a binary operator. The first thing that you want to pass on the left-hand side, the first operand is the string, the property that you're looking for. And on the right-hand side is the object that you want the in operator to look into. That's it for in. So let's move on to equality operators. So equality is about testing whether or not two things are equal, two values are equal, or two references are equal. So there is a little bit of there's some wonkiness in JavaScript equality. I am going to introduce all of the equality operators, but I am going to present an opinion of a best practice to do instead of. But let's get into it. Let's first get into it. So let's see if 5 is equal to 4. We get back false because in fact 5 is not equal to 4. However, if we want to say or ask the question, is 5 not equal to 4? We'd expect that to be true because 5 is in fact not equal to 4. The way that we do not equal in JavaScript is with a bang or a exclamation point. So we get 5 not equal 4, and look at that, we get back true. Let me go ahead and clear this out to make it a little bit easier. So we'll do that. We get back true because 5 is in fact not equal to 4. This particular equality is I'm going to call it the devil. We're going to get into reasons why in a later video, but I'm going to show you why this is particularly an interesting thing. Here I just said is 5 not equal to 4, and that's true. But let's change this 4 to 5, and what do we get back? We get back false. Well, we would expect this to be true, right? Because 5 is not equal to a string. A number is not equal to a string. That's the wonkiness with this particular set of operators, is that it's not testing strict equality. This is doing something called coercion. We'll get into that in another video, which can lead to all kinds of subtle bugs that you would never expect. So how can we get around this? Well, we use strict equality. Strict equality in JavaScript is 3 equals or 2 equals, or let's do this. It's this. This is strict inequality. So we say not equal equal, because strict equality is equal equal equal. So we see here that we get back the value that we expect, true, because 5 is not equal to the string 5. Or in other words, a number is not equal to a string. Look at it that way, because remember, this type is a string. It may say 5 in here, but in actuality, this is a string. It's not this. We can't do math with a string. Now let's ask the question: is 5 equal, like strictly equal to the string 5? And we should expect to get false. Oops, I don't know what I just did there. We get back false, because remember, a number is not equal to a string. Don't look at the actual, like the string value. Don't look at that. Just look at the fact that this is a number and this is a string, and they can never be equal. However, if we were to just use the equal operator, just the basic equality operator, this would return true. Weird, I know. That's it for the equality operators. They're fairly simple. We also have like bitwise operators, and we also have logical operators. The ones that we're going to cover today are the logical operators, because they are quite useful. So we're going to start off with the logical AND operator. So we'll do AND. We're going to do a truth table for AND. And because it's a binary operator, it's going to have 2 inputs. So we're going to say A and B, and then we want to know the result or the output. So we'll say output. Now, to make my life a little bit easier, I'm going to do some shorthand here. So I'm going to say that T is equal to true, so that I don't have to write it, and F is equal to false, again, so I don't have to write it. You also may have heard that computers see everything as 1s and 0s. So true is typically 1, and false is typically 0. All right, so let's first put in our inputs. So we can have a false and a false. I'm using 0 here. Actually, I won't use 0. I'll use the F and F. So we have F and F. We also have true and F. We also have F and true, and we also have true and true. These are the 4 possible values because we only have 2 inputs here. And because these are Booleans, there are only 2 potential values for Boolean. So we only have 2 to the 2, which is 4. So with AND, the way this works is we only return true if both of the inputs are true. In other words, this is the only input that's going to give us true. Maybe I should do these things right here. Oops. How do I do? Yeah. So that means that every other output is going to be false. All right. So AND is asking the question, are both of the inputs true? If both of the inputs evaluate to true, then the output evaluates to true. That's the only time this will happen. So let's do OR now. So we'll do A and B. Our output. Sorry for my handwriting. Hopefully you can read it. So we're going to do the same setup here. We're going to do FF TF, FT, and TT. Now the OR operator says that you return true if at least one of the operands is true. All right, so FF, they're both false. So we're going to get back a false. However, the second one is true false. We have at least one true. So the whole thing is going to evaluate to true. And we also have false true. We still have one true. So the whole thing is going to evaluate to true. And the last one, we have two trues. So no, that's just going to evaluate to true. If you pay close attention, you'll notice that OR is very much the opposite of, well, it's almost the opposite. It's very close to the opposite of AND. So let's move on to the next one, which is the NOT operator. And this is going to be our very first unary operator. Unary means that it only has one operand that it operates on. So let's go ahead and do NOT. Oops, let me also write that this is OR. And we also need to put in NOT. So we're going to do the same thing. We're going to say NOT. We're just going to do A because there's not, remember, it's a unary. So it can only have one out or one input. And then we're going to have an output. So because we only have two potential values here for Boolean, we can have either false or true. NOT basically flips the Boolean. What I mean by that is it gives you the opposite of whatever you give it. So in this case, if we say not F, we're going to get back T. I'm not sure how that changed, but all right, whatever. If we say not T, we're going to get back F. That's not. It's very, very, very simple. And you can actually combine these to do some quite interesting things. So let's play around with that a little bit. So we're going to ask, before I do that, let's introduce the syntax. So logical AND in JavaScript is 2 ampersands. The ampersand is Shift-7 on your keyboard. So you just do 2 of those together. And because, remember, this is a binary operator, we need to have a left and a right side, right? So let's start off with doing the true and the false. So we'll say true and false. We should get back false but they're both not true, right? The two inputs, true, or the two operands, true and false, they're not both true. So we're going to get back false. And in fact, we do get back false. If we wanted this to be true, well, then we would say, we would change one of these. We'll change this to true right here. Like so, true. Let's set this to false just to prove to ourselves that this is going to return false. And if I say false here, this is also going to be false because they're both false. Remember, the logical AND operator only returns true when both of the operands, the inputs, are true. That's the only time. Let's move on to OR. So we have false or false. This is going to give us back a false because there is no true. Like one of the operands has to be true for the OR operand, or I'm sorry, before the OR operator to return true. So in order to get that to return true, I can make this true. Oops, let's actually use JavaScript. I can make that true. And now the whole expression evaluates to true. Alternatively, I can change this to true and I get back the same result. So notice that it doesn't matter which operand. It's just that one operand, at least one operand is true. And if I change this to true, we'll see that, we get back true, because they're both true. And in fact, there's something called short circuiting, and that's what's happening here. With the logical OR operator, if the first operand is true, then we don't even need to evaluate the rest because only one needs to be true. So if you can imagine, maybe we have something like this here, where we have false, false, false. Let's say we can have like a million things that evaluated to false. Oops, let me actually use the right operator. So let's say we had a million things that evaluated to false, but we had just one thing that evaluated to true, and that one thing was at the beginning. We wouldn't have to do any of this other work here. Like we would see true and we see this OR, and then we know we don't have to do anything else because we only need to see one true. So if I do this, we get back true. Now notice that if the same thing, like we can't short circuit in this case because like we're looking for a true. So we see false, 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 false. Remember, OR is true if there's only at least one true. So we have to look through this entire expression to get there. So no short circuit will happen here. And we'll see here that we get back to the same result. We could do the same thing with the logical AND operator. So we'll go ahead and do this. Except logical AND, this will be a lot harder for it to evaluate the true because they all will have to be true. So what will happen here is that the second we see a false, because this is the AND operator, we know that we don't have to do anything else because the only way that this can evaluate the true is if everything is true. And if the first thing isn't true, then we know that everything isn't true. Right? So if we evaluate this, we're going to get back false. Now, if I put a true here, we can't take advantage of short circuiting because we need to make sure that everything is true. So this will also evaluate the false. The only way to get this to evaluate the true is if all of those operands are true. Now, I know that you may be like, oh, I thought that you said that this is binary. How are you doing like all of these things here? Well, it's important to keep in mind that like there is some type of precedence happening here. So we're seeing that this right here, this false and false go together. So we can actually group these using parentheses. This is the first time you're seeing this. We'll get into how we can use parentheses soon. So we can do this right here. And you'll notice that what's actually happening is they're being grouped. Right, so we are going to evaluate this true and false is going to evaluate the false, and then this false and false, this false and this false. Remember, this evaluates the false. Is going to return the false. So we can actually group these even further. We can say that this is equivalent to this and that. So now we've grouped this whole thing up here together with this. And we can go one step further and complete the grouping here. So notice that I'm just talking about this because I think it's interesting. You don't really need to understand grouping with parentheses just yet. It's just important to know that you can do it.